Good afternoon, everyone. All the distinguished guests, respected faculty members, and all my dear fellow students. Before we start, I request everyone to please stand on their respected places for the university song.
सपना सारवनारा हम ज्योत जलावी सृष्टि नवली सहसा सर्जनहारा हमें वरोदराना विद्यापीठना सपना सारवनारा हम ज्योत जलावी सृष्टि नवली सहसा सर्जनहारा सपना सारवनारा हम ज्योत जलावी सृष्टि नवली सहसा सर्जनहारा
has indeed matter of honor and privilege to extend a very warm welcome to the third edition of our flagship series, Talk at Techo. This initiative brings together eminent leaders and visionaries from diverse industries to share with us their journey, their experiences, and the invaluable wisdom. Today, we are truly delighted and deeply privileged to host a personality who has left an incredible mark on the global semiconductor industry. A leader, a mentor, and an innovator. Please join me in extending a heartfelt welcome to our esteemed guest, Mr. Nilesh Bhagat sir. Please give him a big round. We also take the opportunity to warmly welcome our student dean, Mr. Hemang Taylor sir, Mr. Anup Kothiyala sir, Mr. Kulbhushan sir, and all the various dignitaries who have their glorious presence and has given dignity to this occasion. Now I would like to introduce our guest, Mr. Nilesh Bhagat sir, currently serves as the Corporate Vice President of Network and Storage Hardware Solutions at AMD, a role he has played since April 2022. With 3 decades of illustrious experience in the semiconductor industry, his expertise encompasses RLT design, verification, physical design and system validation, and the leadership of large globally distributed teams driving chipping development and silicon product delivery. Prior to his tenure at AMD, Mr. Bhagat had several senior leaderships at Intel, including Senior Director of Engineering and Director of Engineering in Server CPU and Advanced Chipset divisions, where his vision and technical acumen contributed significantly to advancements in computing technology. Academically, he holds a master's degree in electrical and computer engineering from the Illinois Institute of Technology, Chicago, and he is alumnus of our own Maharaja Sayajirao University of Baroda, where he pursued his bachelor's in engineering. It is indeed matter of immense pride for us to welcome him back to the alumni of the MSU and rising global emirates. I would like to invite Mr. Kulbhushan Gupta sir, a member of our governance team and the director of MAF, to felicitate Mr. Bhagat with a bouquet and a memento. Please give a big applause.
Good afternoon, everyone. How are you guys doing? Good? It's exciting time for me personally to be here today in the campus. So, a little background, right? I think it was 4 months ago that Raj Joshi as well as Rajesh Matrani and the sponsors of Vision 2020, they were in Bay Area, San Francisco Bay Area, to kind of get together everybody to see what their vision is and what the programs are already ongoing for about 4 to 5 years now. Some of us went there as well. My friends, we all went there to understand what the programs are, and then I was coming here for a business trip, and I asked Rajesh, hey, I'm going to Baroda for a week or so. I want to get involved, but I want to start somewhere other than just a monetary donation, right? So he says, yeah, why don't you give a talk to all the students who are very eager to hear from people from industries, different industries, right? So I said, sure, I'll take that opportunity. They connected with Naman. He's my guide for last more than almost 2 weeks now. He's guiding me every step of the way to see what is expected, and we kind of set the journey for last 40 years since I graduated in 1981. I said, that's easy. How much time do I have? It's about 20 minutes. Okay, I said, I'll go quick. And then he says, why don't you just talk about your experiences? Not your life experiences, but your work experiences. So we'll talk about that today as well. And then we'll have a lot of time to do the Q&A. I think there's a panel that we will be talking about. So, from the introduction point of view, I was born and brought up in Baroda. I am Barodian. Baroda name was given after I even left for USA. So it doesn't come natural to me, Baroda. I am still, in my language, say Baroda. I went to Neura High School near Sutagar for my elementary. And then it was all boys school. And then I went to co-ed school, Jeevan Sadhana, in the similar area, and graduated from there in 1975 with SSC, Secondary School Certificate, right? In fact, this year is 50th anniversary for my graduation. So I'm taking a bunch of my friends who are local here for a lunch event tomorrow. That'll be fun to meet all my classmates. I've been meeting with them every time I come here, but this is unusual for me because Every time I come here, either with my family, with my daughters, my son, show them where the electronics engineering group building was, and we take a picture and we go home. But I'm glad that I got this opportunity to address my journey as well as my work experiences to you. Hopefully some of it is applicable to you, some of it is not. And then you take away whatever is the best for you going forward. So, as a disclaimer, I'm here not representing AMD, Advanced Micro Devices. My viewpoints will be my own individual viewpoints. But we will talk about how the industry is overall going, where they are going, how they are doing, etc. The other thing is that I have a variety of experiences in semiconductor industry. All along for 44 years, all I'm doing is a hardware design, either the board level design or the component design, and now maybe even system design. I have not touched much even software, by the way, but we'll talk about it, that you should have interest in a second skill or adjacent areas, things like that. So my talk will be around my work experience in the semiconductor industry, right? I will point here.
Moving. Keep it on the screen.
No, he says point here.
Yes. No, it's come. Yeah.
Little delay.
All right, so we talked about this, right? I'll give you a quick glance at my career. Then we'll talk about the technology advancement, and then words of experience, not words of wisdom, words of my experiences. I think it takes 3 attempts. Here's the timeline. 1976 is when I joined Faculty of Technology and Engineering, and then graduated, 76, and then graduated in 1981. So I did the B Electronics with instrumentation specialization.
5-year course it was that time.
Yeah, 5 years.
That was in quick, yeah. Was a 5 years course, yes. And I see some of my classmates are here as well, Ashok and Nilesh, and so good to see you guys here. I appreciate you attending it. Then after graduation, I joined ORG Systems. It's a computer division of Ambala Sarabhai. So I joined as a design engineer, computer division of Ambala Sarabhai Limited, and we designed microcomputers. These were one room. These computers were one room size. This one has a 64 kilobyte of memory, and it had a magnetic tape drive and a terminal which is only 80 characters by 24 lines. Before I left in 85, that ORG-20 is a IBM PC XT look-alike that they designed. Now I'm going to give you some history here. I want to click it. So, how the ORG system was formed? 1977, nationalists, they came to the power at the federal level in New Delhi. Moraji Desai was the prime minister. They decided that they have an agenda to have MNCs, multinational companies, to have a stake only 40%, and the 60% stake should be with the local companies. So IBM, Coca-Cola, Vespa, Italian scooter company, Philips, these companies were started thinking, what the heck do we do now? IBM and Coca-Cola did not like that idea. They said, no, we want to have 100% stake in our company while we are in India. So they left. They literally left. Coca-Cola left in 1977. So nothing to no soft drinks available, and then you got the thumbs up in 1978. That's how thumbs up started. So a bunch of IBM experts got together, talked to Gautam Sarabhai of Ambara Sarabhai company and say, you're doing so well with chemicals and making so much profit, why don't you diversify? Let's build some microcomputers. They had at that time in the campus here at Vadiwadi, I think it's called?
Nandan.
Nandanwan? Well, Nandanwan was the office, but the Vadiwadi was
Vadiwadi, yes.
They had IBM 1401 mainframe of the room of this size, a computer of this size, and then they also had a Russian computer called EC1030, but they had a punch cards, and it's very slow. So their first device was using a 4004 4-bit microprocessor, a smart terminal. So those days when you go to Air India office or Indian Airlines office, you'll see ORG systems, smart terminals used to enter the data into the mainframe instead of using a card reader which are punched. So that's how ORG systems was formed. By the time I joined in 1981, they were doing Intel 8080 based microcomputers of this size, right? It was the best company to work for in India. So you're born and brought up in Baroda, you went to a great school, MSU University of Baroda, and now you got the best job that you can get in India. Quite a few students from other cities, including IIT Chennai and IIT Kanpur and others, used to come and work for ORG systems. So luckily, again, I was surrounded with a lot of really, really good employees, very smart technical people, and the IBM experts guys, very good at what they did and build the systems that is very similar to IBM. Systems I meant is service and all the way from development to manufacturing to the service. So I was lucky to work for ORG Systems for about 4 years. My classmates went to USA already for higher studies in 1981. And I also always had that thing that no, I need to go get higher education. And I want to be at the same pace as everybody else in the USA and in the world. So after this ORG Systems, there was a Hindustan Computer Limited, SCL, Wipro, DCM, Delhi Computer, DCM, and then also there are other couple of companies who started. That is India's first, I call it a IT 1.0. And then came in 85, I'll give you a little bit of that, where, where's the, huh? Oh, there, I see. So I went to IIT Chicago. I was there for a year and a quarter, not much. I wanted to get things going, but I already learned enough at ORG Systems. I got some basic courses going. This is IIT Chicago. Two notable attendees. Sam Pitroda, who also graduated from MSU University Baroda. He did his master's. And Professor Bhuvan Parekh, who was the head of the department for computer science here. They also attended IIT Chicago. So I feel good that, in fact, I met Bhuvan Parekh before I left for the USA. What I learned at school is that you guys know about teachable moments, but what I learned is opportunity moment. At ORG Systems, before I left for USA, I had looked into some issues that a typical microcomputer had on the 5.25 inch floppy drive. When you close the door, the floppy is spinning and is getting adjusted, and once it's synchronized, it starts reading the data. That mechanism had an issue with the circuitry that is on the board. So we had solved that problem at ORG Systems, and I had gone to a couple of places in Bombay and in Surat to fix those problems. So I knew what it is. When I joined, very first day I was trying to meet with my professor, And then he took me to his office. There I see Intel machines with the similar floppy drives and all of that. I said, this is great. Can I start using it tomorrow? He said, no, don't touch it. It doesn't work. I said, what's the problem? He said, I use the floppy drive from this machine to the other one. It doesn't work. But when I use the third one, it doesn't work in the first one. I said, I know that problem. I have solved this problem before I left India. Can I open it up? But no, you can't open it. This is all under maintenance contract and everything. I said, no, but I know exactly what the problem is. If they're not coming and solving it, he sent me with his technician to a local store. We bought components, we fixed it, and that's it. It's a eureka moment for him. Because with those machines, then he was able to offer a real-time operating systems program or a course. There, the courses are based on what the professor can have in their own cubby, right? So he was excited. That was the right change for me. He went to dean, and then came to all the financial support, and everything started from there. So to me, it was an opportunity moment. You should grab those. You should remember your past experiences and grab those opportunities. So after graduation, immediately I went to work for National Semiconductors and also Chips and Technologies, where I was designing chipsets for IBM PC equivalent systems. So and millions of those systems were out there in the market. There was one chipset for a very popular 486 CPU that I designed. I'm very proud of that because it was the most popular CPU that Intel had, and I had an opportunity to work all by myself on that chipset. So very proud of that moment. So I did the CPU and chipset design for Chips and Technology until '98. I was doing a 2D graphics design for Chips and Technology, and three companies, Chips and Technology, Intel, and the Real 3D, got together and did one 3D graphics chipset design, Intel's first 3D graphics. From the start to the production was 9 months. I was representing Chips and Technology. I was a hands-on, active senior manager, but I got into knowing Intel as such a large company, 100,000 employees, compared to Chips and Technology where we only had 250. So I took that as an opportunity to learn how to work in a large company where quality is no compromise and schedule is the king. In those days, if Intel hadn't made a mistake, it would be on the Wall Street first page headline that Intel chip has a bug. You remember the floating point bug that Pentium had in 1992 or 3, right? So I learned how to maintain the quality without compromising the schedule also. On time, high quality. I learned a lot from Intel on that front. I did the 2D graphics core, I did the chipsets for servers, and then Xeon CPUs, and then of course, lastly I did some FPGA designs as well. So in 2022, I decided to leave Intel and join AMD. I was doing projects similar to what AMD was doing, and AMD was looking for somebody who can not only just do the execution, but also work with a very key customer. I will not name them, but because the product is not launched yet, very key customer. So I got chance now to not only do the execution of the project within my own factory, but also work with a key customer that is doing hyperscaler designs and launching many platforms all the way to support the end users' experiences. So now actually I'm going to talk about technology advancement that many of you already here sitting probably can acknowledge. So back then we had a rotary phone. We dial. Now we have dual SIM iPhones, dual SIM Android phones. Back then we had a vacuum tube radio. On Wednesday at 8 o'clock, Binaka Gitmala would start, but you have to turn the radio on at 7:45, so the tube warms up, and the magic eye shows up, the green magic eye, only then you can get that. As soon as Amin Sayani starts, we used to set the clock to 8 o'clock. That was the whole way to get the clock adjustment done. Now we have Spotify music. It's thousands of songs are available on Spotify. We had a log tables and a slide rule. Now we have a chat GPT. I feed in my complex program, it solves the equations for me. But log table and slide rules is what we used until third year, and I think after fourth year we were allowed to use the FX series calculators. Schematic captures. The designs were captured using putting all the standard cell gates together, AND gate, NOR gate, flip-flops, latches. Now I can write in a hardware descriptive language, HDL, describe the function of the module and to spit out the design for me. And the last one is, we had IBM PC XT with 1 megabyte memory, 1 megabyte. Now, my iPhone has only 256 gigabyte memory. Things have changed in 40 years significantly, but the point that I want to make is, our generation is really, really fortunate to have gone through this technology advancement, and for many of us and all of us to be part of that historical advancement. I personally feel very fortunate to have seen all of this. Now, I'm not saying that you guys not. You guys will be exponentially doing things and telling your grandkids that, look, back then I only had a chat GPT. It took 1 second to give me the answer. Now it also knows that I'm thinking something and giving me answer. Right? So we'll see how it goes. But we feel very fortunate. I feel very lucky to be in this era where I got to learn the basic vacuum tube amplifiers to now developing AI products. So few key performance indicators, right? Back then there was 8 megahertz CPU core frequency. This is the core frequency that you feed in, that the clock runs and then you get the instruction going. Now it's 4 to 5 gigahertz. Oh, sorry, yeah. The memory capacity is in terabytes now. The 8080 was processing 200 to 300 kilo instructions per second. Now we are running at 1 billion flops, floating point operations per second. 1 billion floating point operations per second. The form factor, I showed you the picture. It was a room-sized computer. Now it's in our palm. The form factor has significantly reduced power. It was always plugged in. It was always plugged in. Now the laptop has a 10 to 24 hours battery life. The usage was mostly for office. I talked about, right, LIC. I used to go and install computers and maintain those at life insurance company in Surat, and Bank of Baroda used to have a lot of these ORG system. But they were for large corporations. Now the phone is a wallet, it is camera, it is my map, it is the music boombox. It's got everything in that one. All right, so I'm going to move to my work experience now. Okay, the next couple of slides are about my work experience. One of the things I want to talk to you guys about is, I personally differentiate between job and a career. Job is short-term view. career is long-term view. I thought about giving a T20 versus test match analogy, but I'm saying, I don't want to go there, right? T20, you go hit and then get it done. In test match, you won't stay there, have a strategy. Growth is not something that people who do the job looking for. They're looking for, it's education to earn the income. While in a career, you're continuously learning and you are developing new skills to do more, better, faster for your own advancement as well as to add a value to the company. In a job, you're not really looking for recognition. Thumbs up at 5 o'clock when you go home is good enough for them. While in a career, you get motivation when you get recognized, when you get rewarded. And recognition and reward is not always about money. It could be higher responsibility going forward for the next project. In the job, the scope is very stagnant, it's very fixed. Year after year or project after project, you do the similar thing. You're good at it, but you are happily doing that for yourself and for the company. While in the career, your scope is increasing. You have a broader responsibility coming to you. The short term, result based is the goal there. The goal is really, what's my job today? When I'm driving Monday morning to work, what I'm going to do it by 5 o'clock when I get out of there, right? While your career, you set the goal, then you do the strategy. From the strategy, you come up with a plan, and then you execute plan. I'm not talking about every day. I'm talking about, you think about it for 5 years. Say 5 years down the road, what's my goal to get there? What's my strategy to get there? What's my plan? You get your master's degree, you go and get some training outside of school, you will read some books, you have a mentor who can teach you. All of that is part of plan, and then you execute. The impact that people create through job is narrow. But the impact when you are developing your career is a lot more than just your own organization. Sometimes it's even just at a business unit level. Career has a social recognition. You get a title. You write down in a LinkedIn that now you are a senior manager. Your neighborhood, everybody knows it. I'm going through this for my employees in Hyderabad. They want that title. They want to do well in their job, in their current position, so that they get the next promotion after the next promotion. It's a good thing. You get a financial advancement, yeah, and you do get a gratification of achievement. I talked about how proud I was with my 486 chipset that I did, which sold millions and millions of it. You're talking about literally millions, 150 million per unit, per 150 million units per year, and it had a long life. Right? So I wanted to talk about job and career. Think about it. I think career goes a long way in this day and age. Job, if you have stagnant scope, pretty much with the tools and methods and advancement in AI, you will have a struggle. Then I want to talk about some drivers that enables you to develop and build that career. So we talked about career is growth and development, right? Continuous learning, either through training or from the past mistakes, is a long-term view, and it is adding value to your company as well, where you work, or whether your own company for that matter. So the drivers that enables and builds a career are, this is my view of it by the way, is volume of work. Higher the grade, higher the position, you tend to do more. You are working on today's program, but last year's product that you launched, there's a customer escalation that you may have to work on that on the same day that you work on current program. And you may have to look at the definition of the next program that the company is developing. So it's volume of work. Or if you are developing an intellectual property of your for the project, but it is going to 5 different products. So you should be able to handle more work as you grow in your career. So that definitely is one of the drivers. Quality. And by the way, there is no definite order here. You can do few or all, but these are all, from my point of view, very important drivers. A junior engineer making one mistake in the test that failed, and now you have to redo the test tomorrow morning, impact is less. A senior manager just so happens to have forgotten one aspect of the design check before the design is sent out for manufacturing, it could have a major impact. So the quality is important as you grow in your career. Complexity. When you start your new job as a college graduate, you will be given a design that was already done, but now incrementally we have to make it work for the next program. You will be given a low complexity problem to solve. But when you grow, a junior engineer pushes the button to measure the power of the board. It is 25 watts, great. But a senior engineer, senior engineer, he will be given a task to figure out how a 25 watts board can be used, reduce the power to 17 watts. He has to take the 8 watts out of that, redesign board or a circuitry or a configuration, change something, firmware, driver, whatever. That's a much more complex program. So the complexity will go higher as you grow in your career. And you have to kind of look for that to support that in your career. Velocity. This is the pace of work. How quickly you get to know the problem, how quickly you understand the problem, how quickly you can come up with the options for solutions. It could be based on your previous experiences. It could be asking for help in your large organization, saying, hey, I need help here. Or it could be coming up with a new tool. But for the new tool can give you automation. So pace of work is also going to be important as you grow in your career. Sphere of influence. When you're a new engineer coming into the organization, all you know is the person sitting next to you, in front of you, and behind you. Small team of 5 or so. But when you grow, you are going to influence larger number of business units as well as other programs. Your sphere of influence is going to grow. The important aspect here is influencing without authority. When you are trying to get something done with the other business unit, they do not know you, they don't work for you. So now you're trying to get your idea and getting an influence for them to implement that can go into your design. So you have to learn all these techniques, and the most important technique which only can be learned by experience, in my opinion, is influencing without authority. My own team, I can tell them, let's do this. I direct them, they will do it. But getting it done by my supporting business partners, it's a skill that you have to develop. And you develop that over a period of time. But for that, you need to have the passion to say, no, I want to grow. Otherwise, my scope can be stagnant and I'll be happy saying, that I don't do that. Somebody else has to do the influencing with the other group, right? So this is very important as you grow in a large organization as well. And versatility and agility. I really would encourage you to not just be good at what you have done or you are good at, but look around. What's coming from upstream, what's going downstream, so that I can be successful. So what do I need from my upstream teams? If I'm doing design, architecture team is there, what do I need from them for me to do a better job? and what is going to be consumed by the downstream teams from me so that I can do better for them, and eventually the product wins, right? The eventual goal, the common goal that everybody has in organization is to make it successful. It's not design successful, it's not verification, it's not manufacturing. Everybody has to come together. And the agility to adapt to the changing situations is the key. Change is constant, believe me. Change is inevitable. Change will happen. One of the qualities that you should develop is adapting to the changing situation, whether it's changing a manager, changing the field, changing the company, working from upstream architecture to design to manufacturing. All of these are so important. And broader the knowledge you have, better you are. And the business acumen, right? You need to know how so and so things are happening. A new college graduate, a new college graduate is worried about 1,000 employees getting redeployed in other sites. The company is about 50,000. Fair enough. You have to explain to him what is going on. The senior people understands why they are doing certain things that they are doing. I do have, I don't know how much time, I do have to make this point though, right? I want to talk about task and accomplishments. Task completion is a job. But accomplishments is making a business impact. It's two different things. I'm done with the task. I ran 10,000 tests. I'm happy. I'm going to run 10,000 tests again because the design changed. That's task. But if I figure out that after outside of the 10,000 tests, the 3,000 tests are useless and not adding any value, not giving me any coverage, I take it out and deal with the design with 7,000 tests, I reduce the compute power, I reduce the regression time. That's a business impact because less computers are used to run the same coverage. So I differentiate between task and an accomplishment. So I ran into this, I came across this formula a long time ago, which is happiness is equal to results minus expectations. If you accept the expectation here, you set the results, you're happy. But then I formatted that into accomplishment. Accomplishments is equal to results minus expectations. So higher the expectation set, you will work harder and smarter to meet that expectation, to get the results that meets the expectation, and you will be happy. And you will have accomplishments. Accomplishments is making a business impact in a positive way. Yeah? The new formula that has been out is accomplishment equal to reality minus expectation. The reality is different. You're not controlling few things. Whatever is under your control, yeah, you can do it, but that could come from a left field and pose a lot of risk to you. So there are going to be risks as you execute your plan, and those needs to be mitigated upfront. So accomplishments in this case will be reality minus expectations. Accomplishments gets recognized. Accomplishments gets noticed by your manager, your senior management. Those gets rewarded, those things get recognized. Other traits, I'll go quickly on this, right? Have a mentor. Find somebody who has been in the industry for a while and is ready to talk to you, not only when you have concern or issues, but also on the positive side as well. Take pride in your work. What you do is good, is changing the world out there. Whether it's a machine that you are fixing it for medical devices or something that is important in the school or in your personal life. Take pride in your work. Learn the adjacent areas. Keep an eye on it. You don't need to do that. You're solid with what you do. But keep an eye on what's going on. That's how you're going to grow. Right? Continuous learning. You have to learn from mistakes, you have to learn from success, but with AI going on, you have to be riding that wave, right? That's why my last one is, but be a team player. It takes a village to develop a product. Whether it's in your own company where you're an entrepreneur or in a large corporation, it takes a lot of people to make a product successful. You want to be a team player. You want to support others. You want to get their ideas into yours and make a good, successful product. Ride the wave of AI. No escape. We will not be able to escape AI. Trust me. We'll have to ride it. We have to know it. We have to figure out how to use it. Most importantly, which is not coming up. Now it's here. Most importantly, have fun. Okay? I think that's my last slide. Thank you for listening. I hope it's useful. These are my work experiences. And I appreciate your time. Thank you.
Thank you so much, sir, for this amazing insights. I would request you to be please on the stage, and I would like to invite our moderators for our special conversation. We have 3 dynamic moderators, Anirudh Prasaram, Manshika Mathur and Shivam Singh. They will be steering around the theme past, present and future, taking us through the sir's insights and journey.
Good evening, sir.
Good afternoon. Yeah.
So I had a speech. This was very insightful. And so my first question is, what do you miss most about Techo, and how the aspects of your undergraduate education most shaped your engineering mindset?
So before I came here, we had a brief introduction in Dean's office, and I've been hearing that the school is doing phenomenally good, particularly computer science and computer engineering. And your first question is, what do I miss? I'm not complaining, but back in the day, we had limited resources, I would say, and we learned by books. But if I had to redo the whole thing, I'd be excited to redo that Bachelor's of Engineering again, because the resources are so much. We had to study in between the aisles of the library here, but now the resources are so much, including the university providing all the resources. That is very positive from my point of view. That would be the thing I missed. I think from my electronics engineering domain perspective, what we have learned was so relevant in our professional career. We, even today, right, this morning, literally, I had a meeting with my team in Hyderabad to solve a problem, which was a transistor level, right, literally a transistor level, that Professor Agarwal taught us microelectronics. So what I learned in control engineering, in statistics, in microelectronics, material science, I'm still using it. Now, I'm personally, because of an engineering organization, I'm part of an engineering organization, so I have to be engineering savvy still today, right? I'm still pretty hands-on. And from my perspective, what I have learned at the Faculty of Technology during the 5 years course, very relevant.
Okay, that's I like that answer. And this was like very nostalgic from your side, I guess. And from that, my another question is, we as engineering students I always wonder if what we are learning right now is going to help in future, in real world. So with that context, can you guide us?
So, and we talked about technology advancement, right? All the way from rotary phone to iPhones and music and wallet and everything in one device. I think the technology is going to advance at a much higher pace than what has gone through the last 40 years. Okay, I am expecting it to be exponentially go higher because what's going to happen is AI. First thing AI will bring in is the productivity. With productivity, things will be much faster, quicker. The smaller and cheaper, all that will come later. But the faster and quicker will be the first results of the use of AI. So I expect that what you have to learn here, you have to learn outside of your coursework, outside of your normal teaching in the semesters, right? To cope up with that pace at which that technology is going.
Okay, sir. You spent 22 years in Intel and were promoted multiple times in your tenure. So, give us insights on your transition from Intel to AMD. And another question is that Intel has not done well in last several years, as in comparison of AMD. So, what's the reason behind that?
Yeah, so no, I think when I started my career with ORG systems using 8-bit microprocessor, it was my dream to work at Intel and develop Intel CPU, okay? It was my dream, to be honest. And yeah, I started off with 2D graphics, chipsets for CPU, but in 2010, I got a chance to work on Intel CPU called J-Town, which is a very innovative right-hand turn for Intel. So I do feel very, thankful to Intel for providing me all those opportunities. Intel was at a junction where they were trying to figure out what is their core competency, right? And where the market is going, where the industry is going, and how do we use 125,000 employees in a way that can do a good return on investment. They spread themselves too thin. By the way, these are not my AMD title views. These are my personal views. They spread themselves too thin in different areas. They grew too far for too long. Now I think the headcount is coming down to like 60,000 or something for the employees. So it's significantly reduced in their new charter. The second thing I think that happened in Intel is they had the manufacturing prowess for like, I don't know, last 5 decades, right? They are the best in terms of getting semiconductor manufactured. TSMC was number 2, the Taiwan Semiconductor Company. But at one point where they were having issues in their manufacturing facility, which results into yield. So what happens is there's a wafer. It's like a disc, 12-inch, and it has all these small dies. So it has probably 500 chips in there, right? And you cut them and you assemble it and it becomes a chip. Not all of them will work. Out of 12-inch wafer, you will get 500 chips. 400 will work, 10 will just throw it away because of manufacturing defects. It's a very precise process that you have to use to build those wafers. And at one point in their technology advancement, they had so-called yield, number of good parts coming out of total parts manufactured, yield was low. because one of the reasons our yield was low is the chip was too big. When it's too big, it's difficult to find the faults in there. You have to do a testing. And that made them to change the strategy to chop the chip into multiple ones and make it a discrete. And that took some time. This is an opportunity for somebody else like AMD to get in. That's exactly what they did in 2014-15, I think. If you look at the graph, 2015 was the AMD picked up. In 2014-15 is when Intel went down a bit. They try to recover. AMD is not, they do not have the fab. It's a fabless. They manufactured their chips through TSMC, Taiwan Semiconductor Manufacturing Company in Taiwan, right? They had it before, but they got out of the business. Intel is trying to recover. It's good for the overall the world, because right now we are relying on one company to do all the chip manufacturing. So I think that the transition of the manufacturing to give it to TSMC was a one inflection point. Spread it too thin to do many projects, as well as AMD just got into the track and took off from there. These are the kind of my own thing about why Intel is still trying to get back into the business.
Thank you, sir. Now, Ashia.
So you mentioned there's a crack which AMD completely took advantage of, right? So there was an edge which AMD used via TSMS, right? So how is your company currently using that crack, using that edge to drive innovation further?
Yeah, so both on the client CPUs, which call it the Ryzen series, and on the GPU side with the Instinct series, we have a solid roadmap. Last year we launched something called MI300 series. It's a GPU, mostly used for training, not inference yet. And on the server CPU side. So today, if you are trying to log into Google Gmail account, there are authentication servers, and thousands of it. These are your single one, they call it a 1U or 2U, right? These are like a pizza boxes into the refrigerator size rack from top to bottom. At the end, at the top, there is a switch, Ethernet switch that talks to the next refrigerator, to the next refrigerator. This is what the data center looks like, right? The so-called back room. So those are server CPUs. AMD is doing very well. Where 3 years ago, Intel had about 85% market segment. Now, I think we are pretty much even in terms of percentage of the MSS market shares, market segment share, right? So, in all three fronts, client CPU, server CPUs, data center CPUs, as well as GPUs, we are inching up. GPU, NVIDIA is doing amazingly well, right? They've been around for like decade plus in this field. They have advantage because of the CUDA software, which is a very proprietary software that they use. They have a large customer base. But the AI, the pie is so big and the pie is growing. So even if you get a 1 piece, 2 piece of that pie, we are good. That helps feed our R&D, and then we keep doing more and more. So then I think it's launched. Now we have a next series called MI400 series that my team just did another chip for that, was taped, so-called tape out for manufacturing last week. So it's a roadmap now. We are not just doing one product to make the customer happy. Along with that, just like NVIDIA, which is providing a system solution, right? It's not just they do chip, they do system design, and they provide software, CUDA. So all the components that customer needs, AMD up until now was providing an ingredient, but not the whole recipe. Now we have a recipe. We acquired a company called ZT Systems. They will build all the racks for us, and we'll scale. So we have a full recipe. We're cooking it. We'll have the whole system design done. That is the next thing for us, is to provide a total solution from chip to software to systems.
So you mentioned NVIDIA. How is AMD competing with NVIDIA in terms of AI? And what else is happening in comparison to Intel? Are you still competitors with Intel?
So NVIDIA is focusing on GPUs. There is a market for server CPU as well. I just talked about it. There are all the hyperscalers where you need all these authentication servers and application servers and storage servers. So we are doing very well against with our Epic series against Intel's Xeon series. I just said that yeah, we are distant number two, but the pie is bigger. We are happy. We will get there. We will get there. We got the solution for training. Our next series, MI400, is really good for inference as well. We have I think it's announced while I was flying in here. I heard Lisa Su announce that, or maybe Larry Ellison from Oracle, that we have a relationship developed with Oracle to build a massive data center, something of the order of $500 billion or something. So Lisa's answer to Fox Business News anchor when she asked the same question, Lisa's answer was, in computing, there is no one size fits all. There is market for every segment. We'll inch up every time we go with the next product in our roadmap.
Right, sir. Thank you. My last question is that as a PE student, fresh out of college, when you joined the industries in ORG systems, so how was your experience? Would you consider it to be positive, or maybe you should have done an ME first, or is it that the industrial experience?
No, that's a good question. Thanks for asking that. All along for last 40 years, I still feel that my best 4 years in my career was working for ORG Systems. Absolutely, no doubt about it. I say that to my current team members, and I say that to people that I am on a WhatsApp group with my ORG Systems WhatsApp group. One thing that I had, along with some of the other friends who also joined ORG that time, as I said earlier, that bunch of IBM expats, people from National Cash Register NCR, people from Steady Univac, they were the management. And these guys were down to earth, hands-on. GMs and VPs would come to production floor after 5 o'clock when the meetings are over, sit down with us, just like this table, literally like this table. We have the cards here, and they look at the ground and VCC noise, right? And we'll fix the issues. They will help us. We are surrounded with these experts who are very much, hands-on, have a good business and knowledge as well as engineering knowledge. So I'm very fortunate. So and they were ready to kind of mentor us and teach us. So it was a very positive experience for me in August of 1981 when I started. No, it was very positive. I quickly learned, even though we had only a 4-bit CPU SAP. I'm looking at Ashok Furnace here. He was my classmate. I think we had a SAP, simple as possible CPU that we had to construct, in our lab here. That gave us a good understanding as to how do you do add and subtract. But with the 8080, with the 256 instructions, I think was a very interesting experience, and I really enjoyed it.
Thank you for answering my question. I'll now hand over to Shivam.
Thank you.
Yes.
Okay, sir. So my first question for a future perspective is, what core qualities will future leaders in semiconductor need in future, and how will the roles shift in the industries and workspace?
No, it's a good question. Yeah, I think difficult to predict what's going to happen, but we know AI is happening, and we know that the paradigm is shifting in the world. The norms are changing. I'm talking about geopolitical issues and all of that, right? And it's not just engineering for the leader to know. As I said this morning, I was with my team solving that problem. That is good, that will continue. But what the future leaders, senior leaders, needs to be good at also is to understand the nuances of the world, nuances of the environment situations. How do I reduce the power in my chip so that I don't consume as much, or I go with alternative energy? How do I work with my partners who are also struggling? But what's the so there will be more than just engineering that the leader will have to do. I'm not saying that we were fortunate, but we were lucky that the world was stable and calm, and the norm that we had established for the last few decades continued, but that is changing now. So it's not two-dimensional anymore, it's multi-dimensional problem that the future leaders will have to kind of grasp on.
That's a very insightful answer, sir. Moving on to the next question. It's like for a student's perspective, what should aspiring engineering students with leadership potential choose, MTech or MBA, for the best career impact?
To start with, I believe and I'm a proponent of formal education. Period. I think formal education has a lot of value. It's not easy to just learn everything by looking at a YouTube. YouTube can provide a point solution. But what you are learning here in the classroom is basics, that's fundamental, it is scalable. That what you learn here in electronics or thermodynamics or civil engineering, it provides you a basic fundamental knowledge that can solve different problems. I cannot become a plumber by just looking at a particular YouTube channel to solve a particular problem. That is just going to be a point problem. It's not going to be scalable. For scalable. So now the answer to your question is, I think both are valuable. Both, and I'm not trying to be diplomatic here, okay? My son got a MBA from Yale and he has a different view than I have maybe. I think both are valuable. Both MTech and getting into engineering leadership and MBA degree with a managerial and business level leadership has a value to be added to a company or your own company or some large corporations. Both are intermixable, kind of difficult, but in a given large corporation, both of these positions exist. They are supplementing to each other, and to pursue MBA after certain technical degree is a very good idea. So if you're in a marketing with a product development responsibility, knowing the core fundamental technology or a problem that you're trying to solve is very important. But I value both MTech degree as well as MBA. But after MTech or MS with 40 years of experience, I can do my own MBA level business discussions, right? AI will change MBA, okay? But that's a separate topic to discuss some other day.
Thanks for clarifying, sir. My next question is on AI only. Okay, so will AI and robotics actually displace human engineers for the most technical design and engineering jobs by 2050? Looking at 2050, what skills should we build starting now so that we have meaningful professions 25 years out?
This question has been in everybody's mind for about 2 years now, 2.5 years, right? This thing started. I think AI is not going to displace jobs, but if you know AI, your jobs is secure. But if you do not know AI, somebody else knowing that AI will replace you. AI is a productivity tool today, generative AI, right? My program manager, when he's running a meeting with 25 people on the call, everybody's talking, instead of him taking notes, every little detail, the co-pilot is running, right, in Microsoft Teams, the notes are taken, the action items are taken. Before, you will be typing all these things after the meeting is over for 3 hours and then send out notes. Now, he looks at the co-pilot, he summarizes it, he sends it out, right? So 2 hours saved for him per day, he's going to be able to do something else. But if it doesn't know that, he may lose his job if somebody else I find with similar quality. Now, long term, you talk about 2050. I don't think even I can even predict how good AI will be next Monday. There are people who are talking that when they come out of boardroom with all the board of directors talking about product, next morning the plans change because somebody else already is working. So AI is going exponentially fast. So I can't say about 50 years or 25 years from now. But I think the thing to learn is generative AI is a productivity tool. It'll tell you what to do, right? But the agentic AI that decides things for you based on your routine, based on your past experiences and your future aspirations and all that, that is something, and that along with the robotics is definitely going to be changing our lives significantly. What do we have to do? Ride the wave. As simple as that, right? Get to the implement and use it. Right? Be very cognizant about how people are using it, how industry is using it, how is it used by SpaceX, how is it used by Tesla EV car, right? That knowledge will help build future products, both in robotics as well as AI. So just riding that wave itself, I think is a basic fundamental thing we should be able to do.
Thank you, sir, for the answer.
So I have one last question. This is for our audience today. So you mentioned that AI is very important and we should learn how to ride the wave, right? How do we develop our skill set as engineers in the making? How do we develop our skill set in a way that we make our jobs into our careers, or we make our master's degree or an MBA into our careers that not only make us grow but also, secure a position in our career, exponentially and also long term? How do we do that?
So there are multiple reputed universities, including MIT and Stanford. They provide free classes on AI for all different engineers, not just the electronics and computer science engineers. I would suggest you guys to kind of keep an eye on it and register yourself. It's free, it's online. And then you get to know what's happening outside of India, outside of the your adjacent areas, right? So from current education point of view, that's what I would suggest. If we, I don't know whether we are offering any AI courses or not, right? But I think getting the extended courses by some of these reputed universities, and your eagerness and your, I talk about keeping eyes and ears open. That's probably what I can suggest for today. Yeah.
Thank you, sir.